Interval scale. So an interval scale variable, of course, and first needs to be a quantitative variable. And its properties include that data can be put into ordered or ranked categories. Differences between categories are meaningful. There is no natural zero, and ratios are meaningless. So all of these properties need to be met for a variable to be an interval or of interval scale. Here's an example of an interval scale variable. This is on temperatures. So the difference between 100 degrees and 90 degrees is the same as the difference between 90 degrees and 80 degrees. So here this difference is meaningful, it makes sense. But ratios, if you divide 20 degrees by 2, what do you hope to get? So this is something that does not make sense. Okay. And also note that 0 degrees does not mean there is no temperature. It is an actual temperature, and therefore there is no natural zero in this case. So this is one of the an interval scale variable example. So here's the second example on years of birth of 10 randomly chosen actors. So here the actor born in 1993 is 25 years younger than the one born in 1968. So this difference here makes sense, or it is meaningful. And note that the year 0 does not mean there was no year or time at all. Okay, it's very important to take note of that also. And like we said, ratios do not make sense. The year 2000 does not equal to 2 times the year 1000. It does not make any sense. Here's another example of a questionnaire. So you have 2 questions. The first one is that, in what year were you born? The second question is that, I believe that an increase in university registration fees will negatively affect the economy of RSA. So you need to check or tick one of the correct box on how you feel, on your opinion, rather. So the first question, the variable is year of birth. That is just an interval scale. This is already shown earlier. The second question is the opinion. Okay, so it's either strongly agree, and so forth. So if you subtract one outcome from another, what do you get? So what does it equal to? It makes no sense. So this variable is off the ordinal scale. Okay, so the other thing is, of course, let's look at these differences between the ordinal and the interval levels of measurement. With ordinal level of measurement, differences between outcomes or values do not make sense at all. But with an interval level of measurement, differences between outcomes or values do make sense. Okay, so subtract 1. So as a test, just subtract one outcome or a value from another and see if it makes sense. Then you will be able to tell whether this is of any ordinal or an interval level of measurement. That's how you will be able to tell. Another level of measurement, of course, is the ratio scale. And again, like I said, first it needs to be a quantitative variable, and therefore you look at some properties to tell if it is a ratio scale. So the first one is that the data can be put into ranked or ordered categories. Secondly, the differences between categories are meaningful, and ratios are also meaningful, and there is a natural zero. So all of these 4 need to be correct for a variable to have a ratio measurement scale. So here's an example, one of weights The following values are weights in kilograms of parts made in a particular factory. So of course, the machine weighing 200 kg is double the weight of the machine weighing 100 kg. That makes perfect sense. Okay, so and of course, a weight of 0 kg means something has no weight at all. So 0 here means something else. Okay, different from what we saw in the interval scale examples. So the difference between an interval and a ratio scale. Okay, we are looking at that. So here's the weight. So something that weighs 5 kg is half the weight of something that is 10 kg. So this ratio here is meaningful, and visually you look at it from a weight from 0 to 5 and a weight from 0 to 10. So that 0 to 5 is just half of something that is between 0 and 10. Okay. But that of temperature, clearly, of course, you can find a ratio, but it doesn't mean something correct. So, for example, a day that is 5 degrees Celsius is not, or does not mean that it is as hot as, or half as hot as a day that is 10 degrees Celsius. Doesn't make sense. Okay. So visually you look at it like that, and of course the blue line is not half that of the red line. So what then? Okay, so interval scale that has a main made 0, and therefore ratios do not make sense in this case. Okay, that's any variable that has an interval level of measurement. It has a main made 0, and so ratios won't make any sense. So 0 is just a reference point in such a case. Okay. But ratio scale that has a natural 0. So zeros make sense here. And 0 means there is none of it. Okay. The other thing that we look at is data collection. And we define what an experiment is, which is just the process of observing some phenomenon that occurs. So we have two types of, or there are two types that we can use to collect our data. The first one is the observational study. The other one is the designed study or the designed experiment. So with the observational, nothing is being controlled by the experimenter. And the characteristic is simply observed and the results are recorded. But with the designed, everything is controlled by the experimenter to a certain extent. Okay, that's the difference between the two methods. Therefore, here's an example. A study was performed in which researchers observed the effects of smoking on lungs. So here, this was just observed. So this was just an observational study. The second example says an experiment was conducted to find out if cinnamon reduces heart disease in diabetics. Blocked blood vessels contribute to heart disease. So 50 diabetics took cinnamon every day and 50 took none. So after a month, those that took cinnamon showed fewer blocked blood vessels. So again, this has been controlled as you can see that 50 has been given cinnamon and 50 diabetics were given none of that and compared later. So therefore, this is of course a controlled study, and therefore it is a designed study or a designed experiment. Okay, and thank you very much. This is the end of section 1.1 of chapter 1. Thank you.